What's up, everybody? It's time for math class. Today, we're going to talk about a little something called absolute value, okay? Because it's absolute, and there's value to it. So for those of you in the back playing at home, absolute value is what oftentimes kids visually see is a V graph. Ready for it? Are you ready for it? I almost forgot about my microphone. Are we hearing this? I really don't want to have to make this video twice because it's a lot of labor. Let's get to the math. Anything worth doing is worth doing right. Measure twice, cut once. Let's get to the math. First of all, look at my little head. Absolute value at its basis is a distance. Okay, so you can say the absolute value. This is the simplest idea, right? That you put the absolute value bars, and it doesn't matter if it went in the negative direction or the positive direction. It's just the distance. I don't like that definition. Here, let's look at a different picture. This is the idea that it's like, it doesn't matter if it's positive or negative, it's positive. Again, I don't like that definition, but it's a really quick and easy way when you're first learning math or you're first trying to remind yourself what it is of what that is. Because remember, negative numbers, negative numbers are simply a direction. They're just a direction. They're a direction. Okay, let's look at the coordinate plane. Okay, this is the coordinate plane now. And we're going to talk about absolute value on a larger scale. Okay? So when we talk about linear functions, we're talking about y equals x. The basis of a linear function, let's get a picture of that. We're having like intense review right now, but we have just a couple minutes. Let's do it. I'll be over here. I'm in the fourth quadrant. Okay, so a basic linear function is just a line, right? I mean, linear line, right? But I mean that it goes through the origin, and this is the origin right there. Come on, Thompson, right here. The origin is right there, and it's just basic y equals x. So if x is 5, y is 5. Let's go up to this 5. See, these are different 5s. It's different directions. Okay? We're remembering directions. We're looking at absolute value now on a larger scale. Okay, let's get to it. So here's absolute value. So we still have quadrants, although in the picture I got, we don't have here. I'll be down in the fourth quadrant again because here's the origin, 0, 0. Okay, and now you'll notice though, they oftentimes teachers in books and maps will have quadrants 3 and 4 missing because you're only dealing with the positive y value. So the horizontal bar, if you don't remember, is the x, the vertical is the y, and you'll notice it creates a v, right? That's what absolute value does, because all of the negatives ping to be positive. -2 now over here. -2 ends up being +2. And then there's the point. The point is right there, but it's extending infinitely. That's what creates a line or a space or an absolute value, is the infinite dimension of it. Okay, so let's talk about what this is now. So right now, we have a vertex. Let's get back to a linear function for a second. I'm big again. Okay, focus, Thompson. Okay, so the basic equation of a line is y equals mx plus b. When you see y equals x that we saw earlier, like use your thumb and scroll back if you need to. The b is 0, which we call the intercept, and the m, the slope, is 1, right? Because it's 1 to 1. That's how you get y equals x. Because the m becomes a 1, we don't write the 1. The b becomes a 0, we don't write the 0. You just write y equals x. Okay. Now, an absolute value graph has the same principles that you can pull out. There is a slope, and instead of an intercept, there is a vertex. Okay, this is the basic form of an absolute value graph. Okay, now, I don't know why we teachers chose to do this to you out of perpetuity. I'm going to tell you right now, the m from the slope, and Rene Descartes, that's why it's called Cartesian coordinates. He was in like a rivalry with Pierre de Fermat, Fermat's last theorem. They're both French. M is, I believe, meridian is, I'm butchering the French accent, I get that. But the M is where you get the slope, and it's from a French word, okay? That's why y equals mx plus b, okay? But then when other people riffed on Descartes' idea of the Cartesian plane, right? Cartesian, Descartes, It's from his word. Cartography, that's all from his name, you guys. All from his name. But so then when other mathematicians came along, they're like, why M, right? So then they stopped using it for other things. But it's the exact same idea. So when I couldn't find it, but when I teach students, I'll say function of x, that's just y, okay? Y equals M, x minus h, absolute value x minus h plus k. So h and k are standard form things to mean the vertex. Now I want you to know something. Look, I pulled out a pen. So it's like my pointer. It's very exciting. It's high tech. Okay, so you see it says HK. Now, what are we noticing right in here? That's a subtraction. Okay? Okay? So I'm going to write an example with my actual pen. High tech. Okay? Before we get to it, I want to introduce you to this device I found on the internet, because the internet is amazing. And we're going to use it right now. Okay, isn't this fancy? You can see my coffee mug if you want to too. Okay, so let's look at this. Y equals 2 x plus 2 plus 2. Gosh, I put a lot of 2's in this because it's a very easy way to make an example. Just for the difference of it, though, let's make this a 3 because otherwise, sweet Lord, okay? But so I want to remind you all, so this is a 3 now, okay? Don't be confused. We'll make it bolded. So of this idea, y equals a, we call it m, x minus h plus k, where the slope is a and the vertex is hk, okay? And now we're going to remind, this is a graph we're going to graph this on. But let's take, this is high tech, you guys. This is how teachers do it, for real, yo. So if we go in old school, there's xy, okay? And I'm just going to sketch it because it's a perfect 45-degree angle, perfect 45-degree angle when it's just a basic absolute value, okay? This is 45 degrees because all of these are 90. We're throwing out, this is pre-calc level absolute value. And what I mean by that is that I'm expecting you to understand certain aspects of math already. And that's why this lesson is a little more advanced and a little quick rolling, okay? But so this is like algebra 2 level, but you've seen all these things. That's the thing about that mathematics, of course, like anything else. It's like, it's not that you can't, like when I learned to play Beethoven, at first I played it very, very, very slowly. And I could only go through one song or one part of one song. And then when I started to excel at the piano, then you can do more. Okay, so, wow, this is a long clip. All right, so 2x plus 2 plus 3. Don't forget this is 3, okay? And this is our vertex, right? Vertex. And the slope is 1. I went back to m there. You see what I did there? So that's 1 because this is like 1 and 1. And it's right there, okay? So on that, and I'm going up at 10 minutes. So let's analyze this. A lot of students want to say that the vertex is 2, 3, but it is not. Do you see the mistake? It's not, because this is negative. The form is negative. That means whatever this is, it's 2 is incorrect. It is negative 2. And then when you pull it down, 3, negative 2, 3. Everything's a direction. 1, 2, in the negative, 3, 1, 2, 3. You have a slope of 2. Can get that going on. So you go over 1, up 2, over 1, up 2. There's your new slope. There is your sketch. Watch this again if you need to. I'm at 10 minutes. It's a long one, but it's totally worth it. Absolute value. There's a refresher. You can do it! When I wake up in the morning and the alarm gets out of